The previous chapters gave us a good introduction of what vSwitch means and what VDS means, virtual distribution switch, and then vSwitch, which is there by default when we configure virtual machines. Now, virtual machines from VMware. Now, Cisco Nexus 1000V fills a lot of gap that is there in VM. There are a lot of features that need to be added to VM to make it a complete network related virtual environment. Now it is as for if we don't have 1000V, VMware is like an isolated network. The virtual network is not merging with the physical network. Now to have that merging kind of feeling, we need 1000V, Nexus 1000V, which can provide the visibility down to the south level, plus it also can give additional features like writing an ACL for the VM missions and stopping ACL or permitting ACL based on the policy. We can also have port security, we can also have ACL redirect, we can have private VLANs, we can have net flow, both transmit as well as receive. If we don't have 1000V, only transmit is possible. Now we got net flow for both sending and receiving data, quality of service with both layer 2 as well as layer 3. Layer 2 quality of service, we call it as class of service. Layer 3 quality of service, we call it as differentiated service code point, DSCP, differentiated service code point. And this also supports now switch port analyzer, span, meaning I can sniff one of the traffic that is coming from one of the VMware. I can sniff it, I can have a mirror copy of it, and I can sit and analyze what traffic is going from this VM and what traffic is coming inside this VM. No. For doing span, yes, you need an tool to be installed here, SNMP server, or it can be any. Okay, you can use Wireshark also. Yes, that's a good tool, easily available tool. You can have a Wireshark. It can be any tool, but what span can do is it can just take the traffic, duplicate it, and give it to you. And it is up to our comfort level what sort of tool that we can use it to take those data and analyze those data. You can use any tool. Yep, span is a feature in a normal layer 3 switches. We have that feature. Now that is also now seen in a virtual switch now. And we got mobility of network policies, as we were discussing from the beginning. When we do vMotion, the policy gets moved along with the VM machine. So policy is maintained as the VM migrates using vMotion. Now this vMotion and all may look like somewhat big technology, nothing like that. When you see the videos that I'm going to give you after this class, vMotion will be just 2 minutes, not even 2 minutes job, just a minute job, how to move a VM machine from one physical host to the other physical host. It's a very simple job. Now 1000V, again, as we already discussed, it gives the visibility deep down to the south, meaning till the VM level we can see the traffic that is going and coming out from VMs. We can monitor the traffic, as we already seen in the previous page, like we can use span, switch port analyzer, or we can do some quality of service, or we can write ACL and many more things. So 1000V also provides policy based VMware connectivity. Where do we configure those policies? Not on the VM, but on the Nexus 1000V. With the help of that CLI, we configure the port profile and we define it as a port group, and then we give a name to that port profile, and we call that port profile for each VMs. So that port profile will have your ACL, it will have your port security, it will have the VLANs, and it will have our quality of service. Everything is binded to the port profile. We don't do any binding to the physical interface, because we don't have a physical interface here. We have only vEth. So policy based VMware connectivity, mobility of network, as we already know, as we move, the policy never get lost. And non-disruptive operational module. These things were actually, I remember we were discussing yesterday. You asked me a question also. Non-disruptive operational module. We can have VMs, one or two VMs, so that if one VM goes down, we have another VM to backup. But here non-disruptive means, like, even if you have one VSM, if the VSM goes down, it won't really disturb the traffic flow. Now, yes, let's do it. Let's do it. We started it. This is the chapter that I want to finish, and then give you those videos that I want to give you. Now, when it comes to VSM, it is like a control plane. When it comes to VEM, it is like a data plane. Now here we got multiple data planes. If the control plane is a virtual one, we call this control plane virtual application. If it is a physical one, we call it as virtual control plane physical application. So here, so the virtual supervisor module can be on a VM machine, or it can be on a physical machine. We can have more than one VSMs to have high availability. The VMs are seen as a line card. So if the VSM goes down, still the data path traffic will never get disturbed. They will be kept on forwarding. VMs are called as line cards to VSM. Now, as we see the physical interfaces in the show command, we can also see this V interfaces, virtually Ethernets. We just say simply show interface and then V Ethernet. We can see the MAC address given to that virtual server here. We can see what name the server is called as, and then on what module it is, and then this is now 1000V, because 1000 is what controlling this, and it's a part of distribution switch port number 1, distribution virtual switch, DVS. So as we already discussed in the previous class, 1000V depends on DVS. This is the port profile name which was created on VSM and assigned on VEMs, this particular V interface, VNIC. And always, you can see when a virtual VM machine is connected to the VNIC, it cannot be a member of multiple VLANs, so it will be an access port. If it is an uplink port, then it will be a trunk port on this VNIC, whereas on this VNIC we will have always access. And now what? Yes. Yes, you have 3 VMs because this is from 3 different physical server. 3 different physical server, but all these 3 are controlled by one VSM, and this VSM can be a separate server, or it can be one of the VMs in one of this physical host. Still the output will look the same, like this. Now what we see here is, like, we have VMs, And from this VM there are two different type of traffic originates. One, traffic that is related to storage. So we got storage traffic that is originating this side, and we also got Ethernet traffic leaving this VM. Now the Ethernet frame is received on Cisco Nexus 1000V, and all the security checks, if it is there, it is performed. All VLAN, COS tagging, all these are done here, and then it is passed to the hypervisor. So it is the Nexus which puts the VLAN, which makes all the security checks, COS tagging, everything, and sends the Ethernet traffic to the hypervisor. Whereas here what happens is the SCSI traffic, means the storage traffic, it is received on the hypervisor, right? And then it is actually encapsulated with the fiber channel frame, FC frames. Because it is a storage traffic, it cannot simply go through a normal Ethernet traffic as a Ethernet traffic over Ethernet. It has to be encapsulated with FC, fiber channel frames, and it is transmitted to HPA card, host bus adapter. It is sent to a HPA card. It is like a NIC card in your laptop, network interface card. This is like a NIC card for FC, for fiber channel. So we call it as host bus adapter. Now this is one physical card. This one physical card. We here in the picture it is shown like two, but if you see the next picture, you can see here our data Ethernet traffics are coming like this, our storage traffics are coming like this from VM machine. Now this Menelo and ASCII, what is the function of this card is, it separates, it takes the Ethernet card and sends to the LAN, and it takes the FC and it encapsulates it with FCOE and sends through the Ethernet wire. Now this 5000 switch, what it does is it does something called a leap logical endpoint. What is the job of logical endpoint? Here is the logical endpoint, LEP. It takes that FCOE and de-encapsulate it, meaning it takes out the Ethernet and just sends FC to the SAN. That's the job of LEP, logical endpoint. So that's what we see here. The function of 1000V when we have storage. We don't have 1000V to do anything here. So it deals only with Ethernet frames. It adds all the necessary quality of service and other things based on the port profile and sends to the hypervisor, and it is sent to the Ethernet LAN. Here it comes via SCSI, it goes to the hypervisor, and then it goes through HPA, host bus adapter, and before that a FC encapsulation happens when it is sent to HPA, and then this Menelon ASCII, what it does is it converts it encapsulates it with FCOE and sends it, and the receiving switch before sending to SAN using LEAP, what it does is it de-encapsulates to FC and sends to storage area network. Now this gives you an overall picture of Nexus. We got VMware, we got VM machines on it, we got a Nexus OS with VSM where all the control operations are taken place, and the control plane path is kept separate, data plane path is kept separate, VNICs are separate. They are separate modules. That's why when VSM goes down, the traffics are not really getting interrupted. Right. So here this diagram very clearly shows the different types of traffics here. One is the management that comes along with VM. From vCenter, everything is visible. VNICs are visible. VSM is visible. VEMs are visible. So this red line goes everywhere from vCenter. That's the base. VMware is the base, so you will have everywhere. Next is the control. The control is the one which goes between the VSM and VEMs. Between VSM and VEM goes the control traffic, which carries all the port profiles and so on that we configure on VSM. It is given as a control traffic to the VEMs. Packet is nothing but some management traffics like CDP and so on. They are also sent between VSM and VEMs, but as a separate traffic called packet. Data traffic is nothing but the traffic that is going between VMs, virtual machines, and all this traffic should not go in a single channel. They should be kept in a separate channel. So we need to put them in different VLANs. These three terms are very important, because you will see when someone tries to install VSM, Cisco Nexus 1000, you will see the basic requirement is you need to have this 3 port profile created. So these 3 port groups will be created using vCenter client. The other port profiles for the VMNICs, we will do it on VSM. So these 3 port profiles will be created not on VSM, because there is no VSM so far installed. It is done on VMs. How to do it on VMs? It's coming in the coming slide. This is what I already explained. Management traffic, control traffic between VM and VSM and VEM, carrying port profile and so on. Packet traffic, that is also between VSM and VM, carrying CDP kind of messages. Data traffic is the one which carries the traffic that is coming out from each VMs. Now, about the data plane, this VM we call it as data plane. Each VM is a data plane. This data plane is becoming part of hypervisor here. So this data plane, this VMs, they don't learn any MAC address. They do not synchronize between one data data plane and another data plane. They don't synchronize each other. Only through control plane it can be done, and there is no concept of forwarding frame on any ingress inline to egress. So there is no traffic going like this and coming like this without the help of control plane. No ether channel across. We cannot bundle cables or virtual interfaces. We cannot bundle together across the distributor, across the data plane. And internal switching is also done only through control plane, not directly without the help of control plane. Now if it is a physical port, okay, what is this shows us? This shows the trunk port to which the interface is connected. Like we have the host where we got a lot of VMs in it, and we got NIC cards, and this NIC card is connected to a physical switch, and it talks about these ports on a physical switch. They should be trunk, because there can be multiple VLAN coming from this VM missions, hypervisor and VM NICs. So because there can be multiple VLAN, they need to be in trunk mode. That's what this shows. So those things are configured using port profiles. Virtual Ethernet ports. If you want to verify the Ethernet ports, vEth, again we can go to the Nexus supervisor engine. Supervisor engine is nothing but a console on a VM. We can see the console. When you type show interface Ethernet 10, it will show you the 10th mission like this. Okay, here I see only up to 9. I can see the 10th mission's interface status when I type in this command. It will show whether it is up, what MAC address, same as whatever you see in show interface fast Ethernet 0/0. Same informations you can see for vEths. Only difference is this one V. Other things are same. Now internally this is how it works. When we say vEth, we just talk about vEth on VM, but there is also one more LVEth and the port number. So this is actual logical port on the Nexus 1000V. This is mapped to this. When I move this mission, this will change, but we will not notice this. This will never change. vEth1 will not change. It is binded to this VM, but this will change. Now when we do installation, the installation is done with the help of two teams, VMware admin as well as network admin. So network admin will have his own role to do, like providing the virtual center certification. It's a small file, XML file, that needs to be added during the installation for certificate. Likewise, VMware certificate has to be added by the VM admin, and then the installation of VM and VSM done by the Nexus team, network team, and this DVS, distributed virtual switch, and ESXi, adding host, all those things are carried out by the VM admin. So this talks about how to deploy 1000V. These things you are going to see anyway live in that video, which I'm going to give you after this class, where we have VSM. We install first, and then with the help of vCenter we do that, and we get this Nexus VM on the ESXi, and then we start adding hosts to those virtual ports. We can also merge more than one server, any number of servers, and we can have a cluster. These things are shown very clearly on the video that I'm going to give you. So this talks about the port profile. Now this is an example set of entities that you will find on a port profile. You can have private VLAN, the private VLAN type isolated. You can have port numbers, you can have rate limit, quality of service, span, RSpan, and so on. So likewise, we can have different combinations for different departments, like HR, different set of profile, for compliance, for database, for web application, and we just create profile and we give it to the VMware admin. And what VMware admin does is he takes the VM machine according to the need. He picks one of the profile and binds it to the VMs. Alright, so all this can be under a port profile, which we already discussed. So because the port profiles are binded to the VM, as it moves, it will not lose any profile that it needs to undergo. See, this VM1 is moving to this location. Still the number is maintained, the VNIC number is maintained to which the profile is binded. This is the number, VNIC number. You see, sometime before we saw there are two different type of NICs. This VL ETH, this will change, but this we don't talk. This will remain the same. So vMotion also happens here. So there will be very less downtime. So the next chapter is about configuring VM switches. This may have a lot of pictures, which is also seen in that video that I'm going to give you. So that standard VM network switches has got what I see here is there is 2 port groups, and then there are some VMs, and then there are two physical NIC cards connected. And what do I see here is there will be definitely one V switch on a ESXi machine. We can have multiple V switches also, but not really needed because we got VLANs. We can also have multiple if we want. Configuring the existing V switch. Now this I'll just explain to an extent, but it will be more clear when you see that video. Now there is a tab called config, and then there's a small a hyperlink called network. When you click on network, you will get this place, and where you will see a property. When you click on property, you will get a box like this. When you click on configure networking and properties, you will get a box like this where you can have some port groups. When you say add, it will open you this window. Now port group for what? What port group you want to create? A VM machine or vkernel? Different types of port groups we have. VMs for traffic, service console for control, VM kernel for management. Which one I want to have? I can choose one of this, and then I can give a port group name and a VLAN number. When I do that, I'll see that immediately in the pictorial representation. And then I can create a VM machine and add port group like this. I go to the network adapter tag and then select from the drop down menu. When you click on this, you can see multiple port groups which is already created, and we can add it to one of the VNICs. So this is how we attach the port groups. And then in the V switch, you need to maintain for every ESXi machine separately. If you have distributed virtual switch from the vCenter, we can control all the machines, VM machines on different physical host in one place, like this. So we call it as distributed virtual switch. This shows how to create a distributed virtual switch. You right click and then you click on the not new folder, new virtual network distribution switch. Yes. No, wait a minute. Still we have not gone to the Nexus level. This is just preparing for the Nexus level. See, after you create DVS, when you keep continuing, you can see no, these things are created by the VM admin itself. We don't do all this. From where we start is, I'll show you from where we start. Next chapter it goes here. From here only we start. And these things are very clearly shown in that video. By default, you need to have three port groups, like control port group, and then control, packet, and management. So if it is not there, we know how to create it. Even in the previous chapter we saw. Click on add and say this, and once it is done, it is ready for you to deploy 1000V. We will start from VSM first. There is something called OVF file, a graphical user interface, which does all the installation for you. All that we need to do is just say next. You no need to say how much GB of memory to be allocated, how much of hard disk need to be, nothing. Everything is taken care if you use OVF template. All that we need to do is we need to map to the location where you have kept the Nexus iOS software. Same like as you do in GNS, how you map your iOS. Likewise, you need to map your Nexus iOS through this OVF template and say next. It will finish your VSM. So see, these are the requirements. You need not to worry if you are using this OVF template. If you don't use OVF, if you are doing manually, like installing a VM machine, if you are going to install VSM like a VM machine, then you need to make sure you know these things. Our ether type should be Ethernet 1000, and there should be, you can allocate 3 NIC interface card, one for the control, one for the network, another for the management. We need to have 3 GB of disk space, the hard disk space. At least 2 GB memory need to be given. So these things need to be done only when you do manually. If you do OVF, it is taken care. These things are very clearly shown in the video that I am sharing with you. See, this is manual method. New virtual machine I create, and then I say a typical, not the customized one. I give a name, and then I give a disk where it needs to be installed. I say the option. If you click on, you will see Windows 7, Windows 2000. In that you choose this other Linux 64 and say next, and we say the virtual disk space. These things need not to be done if you are using the OVF file, OVF template. Click on this. Memory allocation. Yeah, something like that. Now all this we need to do. We need to say adapter type as Ethernet 1000, and then finish. And go to network connections and click this one drop down menu. You need to add to the NIC 0, you need to add control, profile, port group. NIC 1 you do management, NIC 2 you do packet. Why we do that? So that CDPs will be using the NIC 1, VSM and VM will be using the NIC 0, and VM traffic will use the packet. They won't clash each other. So we are seeing the confirmation. Once we finish that, we will get like this: adapter 1 control profile is added to it, adapter 2 management, adapter 3 packet. All right, and then okay, go to the CD. See, these are all only when you do manual. Again, I'm saying very clear in that video which I'm giving you. Click on CD. Now, where do we add your iOS, Cisco Nexus iOS? Click on CD to that VM machine and browse and say Nexus 1000V. And this also connect at this has to be checked. Connect at power on. Whenever this VM machine is powered on, automatically the operating system will be loaded from this location where you show. And then click on power on and see the installation 1000V new image. It started. Now this is the one. Now initial basic configuration using dialog box, we say yes here. On routers we always say no when a router boots when a router boots, when there is no configuration on NVRAM, it will ask you for this question. We used to say no, but in Cisco Nexus we will say yes and give some management IP address, and we will enable SSH so that this can be remotely controlled using SSH. See, we say yes, and then for these questions you say no, and then you give a name for this supervisor engine, and then out of band management you want to configure, yes, give a management IP address and subnet mask. This can be used for management, and give a default gateway, and then if you want to use SSH, enable SSH so that this VSM can be SSH from the remote computers. If you are enabling SSH, you have to enable RSA key. Say the size, minimum can be 768, and this is how you do, and then finish it off. Right, so this is for additional plugin. Okay, this is for license also done, like extension XML file. We select it, install plugin. I want you to watch video for this. It's very clear. All that step that is there, I'm showing here, it is there in the video very clearly. For high availability, we can have more than one Nexus supervisor engine. So when you type show module, by default 1 and 2 are dedicated always for a supervisor module, active and standby, and from 3rd onwards the VEM comes into picture. Virtual Ethernet module 1, Ethernet module 2. For each ESXi we will have one VEM, so we can have many modules. Alright, I think these are all, anyway it is going to be just pictures. I don't want to just show pictures, and okay, I'll just go show you a few commands to configure profiles. See, these are the commands. We say port profile on Nexus 1000V after we configure VSM. When you click on console on the VMware, it will show you the console like this. There you can go and create as many profile as you want. What is the meaning of this? When we say port profile, we give a name. It's a name to call on ESXi machine. And then we give description. It's an optional one. And VMware port group name. This is the port group name. Oh, sorry. And what do you want in the port group? I want, wherever this port group is called, I want those port to be accessed. So I say switch port mode access. I want to give a VLAN. And we must say no shutdown. And we must say state enable. When you say state enable, immediately the supervisor engine will push this profile to the ESXi server, and there it will be available for you to use in a drop down menu. So we have to say no shutdown. By default it is shut down. You can anytime come and say shut down if you want. In the port profile, as you say access, you can also say trunk. If you're going to create a port profile for uplink ports, we need to say trunk, and you can optionally say allowed VLANs. Okay, then we'll start here. We'll stop here. I'll give you the video. You go through that video. This configuration part you can learn from that video. So next class we'll be starting with